Okay, so in this video, I'm just going to have another look at area and volume. In the previous video, we just did area and perimeter. In this video, I'm going to do volume of three-dimensional shapes and the surface area of some of these shapes anyway. First one we're going to look at here is just called a cuboid, and this is called a cuboid, and we're just going to have a look at the volume of this cuboid here. So the volume is just going to be the length multiplied by the width multiplied by the height. So for example, if our length here was 10 centimeters, our width was 5 centimeters, and our height was 6 centimeters, we would just simply write down 10 multiplied by 5 multiplied by 6. So that's just 10 times 5 is 50, multiplied by 6 then is 300. So we have 300, our volume here would be 300, and because we're using centimeters here, it's centimeters cubed because we were looking at volume, which is three-dimensional in this case. Okay. So the other thing we got to do here is work out the surface area. So if you imagine that you open out this shape so that it's flat, so what you're going to do is find the area of the front face. So what we're going to look at is the surface area. I'll just write down SA. The surface area is the area of this front face here, which is just length times the height. The height is going to be up along here, so it's going to be length times the height. Now, if you look at this front face here, there's actually another one at the back which is exactly the same dimensions. It has a length and a height as well. So we're going to double that. Then we're going to add the area of the side face here. Now the side face is width times height, so it's width multiplied by the height. Again, we're going to double that because we've got a face here, and the one on this side here is going to be the exact same area. Then we're going to do the top now. So the top is length and width. So we're going to multiply the length by the width, and again we're going to double that because the top face and the face on the bottom here have the same area. And that's really it. So in this particular case, it's going to be twice the length times the height. Length times the height, that's going to be 10 times 6. Then we're going to add twice the width times the height, so that's going to be 5 times 6. 5 multiplied by 6. And then we're going to add twice the length times the width, so it's 10 times 5. So it's 10 multiplied by 5 here. Okay, so that's going to be twice 60 plus twice 30 plus twice 50. So that's going to be 120 plus 60 plus 100. And finally we just got to add these up. So 120 plus 60, that's 180 plus 100, that's 280. Now we're talking about area here, so it's centimeters squared. So really what we're doing here is looking at the net of this cuboid once it's flattened out, and finding the area of that net, which is 280 centimeters squared in this case. Okay, so let's have a look at another shape then. Let's have a look at we'll have a look at a cylinder. So a cylinder then is going to look something like this. So you have this circle on the top, you've got an edge down here, another edge down here, and then you've got a circle on the bottom as well. Now this cylinder here will have a height, so we say the height will go from here to here. It'll also have a radius. The circle at the top and the bottom will have a radius. Now the volume then, the volume of a cylinder, is the area of the circle, which is pi r squared. And you just simply multiply, so we have the area of the top here, you just simply multiply the area of the circle by the height. So for example, if the radius here was 3 centimeters and the height was, let's take 10 centimeters. The height was 10 centimeters, so that would just give us a volume of pi multiplied by the radius, which is 3, square it, multiply that by the height, which is 10. So that would be 9 times 10, which is 90 pi. We leave the answer in terms of pi, so we leave pi in our answer. So that would be, again, centimeters cubed, because we're talking about volume. So if you needed that to so many decimal places, whatever, you would just multiply 90 by pi, which is 3.1415, and so on. But I'll just leave it in terms of pi in this case. So that's the volume of our cylinder. Now, when you're looking at the area, the surface area of this, we're going to break it down into 2 bits. If you cut the cylinder down the middle here and open it out, what you'll end up with is the curved part of the cylinder will just flatten out into a rectangle like this. And the 2 circles, then there'll be a circle on the top, so there'll be one circle here, let's say, and another one here. Okay, so this would fold outwards, this would fold outwards, and then the rectangle would wrap around the circumference of the 2 circles to form our cylinder. So just looking at our dimensions then, the radius here is just going to be here, so that's going to be our OR, and this is going to be OR here as well, the radius of our 2 circles. But what about the dimensions of our rectangle here? Well, you can see that if I cut the curved part, the curved area, the curved surface area here of this cylinder down along here and open it out, this length here would actually be the H that we started with. But what about the length here, this length along here of our curved surface area, of our rectangle here in this case? Well, that's just going to be, remember, this part of the rectangle, the length here, is what actually wraps around the circumference of the circle. So in other words, the length along here is just going to be the length of our circle, and we know that the length of a circle is 2 pi r. So in other words, the width of this circle, the width of this rectangle, I should say, here is just going to be 2 times pi times r, which is the length of the circle. So the area, the curved surface area, which is really this rectangle here, so our curved surface area of our cylinder, this rectangle here, is just going to be length times width. It's going to be the area of this rectangle here, which is 2 times pi times r times h, 2 pi r h. If we needed the total surface area then is just going to be 2 pi r h, which is the rectangle, plus these 2 circles. So we want to add on 2 pi r squareds. Pi r squared will give us the area of 1 circle, double it then for the area of the 2 circles. So this would be our total surface area then. So that's our cylinder. In our case, our curved surface area would be, let's see, our curved surface area. If I put in our dimensions here, it's going to be 2 times pi. Our radius was 3, so we've got to multiply by 3, and our height here was 10. We've got to multiply by 10. So our curved surface area would be 2 times 3, which is 6. 6 times 10, 60. Pi, we leave it in terms of pi again. And because it's an area, it would be centimeters squared. Our total surface area then, total surface area is just going to be equal to our curved surface area, which is 60 pi, plus 2 times pi times r squared, which is 3 squared. Our radius was 3. So this is we're adding on our 2 circles here. So what do we get there? We would get 60 pi plus 2 times, well, 3 squared is 9, so 2 9s 18. So we'd have an 18 pi here. So our total surface area then would be 78 pi centimeters squared. So that would be the total surface area of our cylinder. Okay, so let's have a look at another shape. Let's see, we'll have a look at a cone now. Okay, so a cone will look like this. And we'll have a circle on the bottom then. Again, our cone will have a radius, so this is our radius here, and it'll also have a height. So our height will just go from the apex down to the center of this circle here. Now this is our height here, and we're going to call this distance down along here L. So that's the distance from the top of our cone down to this edge here, the edge of our circle. Okay, so let's look at our different formula here. So first of all, we're going to look at volume. So the volume of our cone, the volume of a cone is just going to be 1/3 pi r squared h. So if you imagine a cylinder around this, like here, imagine the cylinder and the cone was cut out of the cylinder. Remember the volume of our cylinder, the volume of a cylinder is pi r squared h, pi r squared h. So we have a pi r squared h here, and we're just getting 1/3 of it to find the volume of a cone. So the related cone is just 1/3 of the volume of the corresponding cylinder with the same radius and height. Okay, so let me just get rid of that first of all. And we're back to our cone again. So the volume of our cone is 1/3 pi r squared h. Now the curved surface area, which is the area at the top here, not including the circle, so it's just this bit up here. So if we were to cut our cone down the middle here and just flatten out the curved part of it, we can find the curved surface area. So I'm just going to say CSA. The curved surface area is just going to be pi RL, pi multiplied by r multiplied by L, this length here. Now, by the way, this if you look at a cone here, from here down to the center of the circle, out to the edge and up here, gives us a right angle triangle. So this here is going to be our height, this is our radius, and this is right angled here. So if we want to find L here, if we want to find the length here, or indeed if we have L and R and we need to find H, or if we have H and L and we need to find R, we can just simply use Pythagoras' theorem. So in this particular case, we got h squared plus r squared is equal to L squared. And this allows us to find any one of these three dimensions given the other two. But anyway, our curved surface area here is just going to be pi r L. And again, our total surface area is just going to be our curved surface area, pi r L, plus the circle on the bottom, which is pi r squared. Okay, so that's really our cone. Let's look at another shape. I'm going to have a look at a sphere now. Okay, so our sphere will look something like this, and we'll have a radius here. So the volume of a sphere is going to be 4/3, 4 divided by 3 pi, or 4/3 pi r cubed. So it's 4/3 pi r cubed. Now the surface area here, which is all curved, there are no flat areas here, so it's going to be our curved surface area, if you like. Our curved surface area of our sphere is going to be given by the formula 4 pi r squared. It's like 4 circles, if you like, 4 pi r squareds. Now what we can do is cut this in half. We can cut our sphere in half so that we end up with something like this. So this is half our sphere, and again in this particular case we have a radius here, same radius as above, but now we have a flat surface on the top. So our volume here, the volume of our hemisphere, I'll actually write it out actually. The volume of our hemisphere is going to be half this volume here. It's going to be half the volume of the sphere. So really that's going to be 2/3 pi r cubed. 2/3 pi r cubed. It's just 4/3. 4/3 times a half, if you like. That's going to be 4/6, which is 2/3. That's the volume of our hemisphere, and the curved surface area. We do have a curved surface area here as opposed to a flat surface area. Is just going to be equal to half of this formula here. So it's going to be 2 pi r squared. 2 pi r squared. And our total surface area then is just going to be equal to the curved surface area, which is 2 pi r squared, plus the area of the circle on the top, which is just pi r squared. So really it's just going to be 3 pi r squared. We can add these 2 pi r squared, so this 1 pi r squared, this is 1 pi r squared here, and we get 3 pi r squared. Okay, so that's the volume and surface area, curved surface area, total surface area of a sphere and a hemisphere. Just want to talk about one last thing before I finish up, and that is a prism. I'm just going to have a quick look at prisms. Now, if you take we'll take a triangle here, and we'll just stretch it on down along here. We'll put another triangle here, and we'll just connect these up. So this is going to be our prism. So a prism here is a three-dimensional solid, so it's a 3D solid. It's going to be a three-dimensional solid with parallel congruent bases. So this is going to be our base here, even though it's not actually on the ground. But you can imagine if we just turn this up so that this is on the surface and this is above the surface, then this would be our base. So we're saying this is our base, and it's the same shape all the way down through the shape. It's the same, it's a triangle the whole way down along until it gets to the end. Same triangle. So the triangle here and the triangle at the very end, and indeed any triangle you draw all the way down along, they're congruent. They're exactly the same shape. They have the same size angles, the same size edges. So a prism then is a 3D solid with parallel, so these two triangles are parallel, congruent bases. So our two triangles are parallel and they're bases. And they're also polygons. So they're triangles or squares or pentagons and so on. So this is our definition of a prism, if you like. We also have what's called a right prism. A right prism. Now a right prism is just simply the same. It's a prism obviously, but it's side faces. So its side faces are rectangles. So you can see in this particular case, the side faces of this prism here are actually rectangles. And also the bases are directly above each other. So in other words, if I turn this up, this would be underneath this one, this would be directly above this one here. So this is actually a right prism here. Okay, so that's really it for this video on area and volume, in particular three-dimensional shapes. So we looked at the volume of a cuboid, cylinder, a cone, a sphere, a hemisphere, and we had a quick look at prisms as well.